All right, guys, example 4 of 4.3. Find the intervals on which a function is A, increasing, B, decreasing, C, concave up, D, concave down, E, local extreme values, and F, inflection point if we have any. So it sounds like we have a lot to do. Ready? A, we want to find when it's increasing. B, let's do one part at a time. Okay, increasing is when the derivative is bigger than 0 because there are no endpoints. I don't have to worry about endpoint. So it sounds like we have to find the derivative. So f prime of x equals negative 4x to the third plus 12x squared, right, minus 4. I have to be careful. I want to take it. I set equal to 0. Then I would like to solve for x. First things first, I would now factor out a negative 4. So I'm going to end up with positive 3x to the third minus 3x squared. I factor out negative 4, so it's now a positive 1 equal to 0. Whoops, can't factor, so I would need to use decimals to find my 0. Technically, you can use your graphing calculator. I mean, not graphing, the quadratic formula and punch it in. But I'm just going to use my decimals here. So I already have it punch in. It's after the factoring, x to the third minus 3x squared plus 1. By the way, you can enter that in, or you can enter the negative 4x to the third plus 12x squared minus 4. That will still give you the same zeros, okay? So first 0 says, let's find the first 0, I suppose. Okay, so that one is about negative 0.53. The next 0 is 0.65, and the next 0 is 2.88. Okay, so now go back to my come on, it's not doing it. There you go. So based on decimals, I have 3 zeros. X is negative 0.53, 0.65, and 2.88. I'm a visual learner, so I am going to draw a number line and see where the derivative goes. 0.53, 0.65, and 2.88. All I'm going to do, guys, is use my end behavior here, okay? So, limits, ready? As x, ooh, highlighter, no bueno, okay. I'm going to do end behavior. As x approaches negative infinity, f of, let's say, negative 100 is what, right? I'm looking for positive and negative. Negative 100 to the third is always going to be negative times the negative in the front, so this is always positive. So positive right here. I'm going to do the extreme one on the positive side. So f of a positive 100 is always positive because x to the third, that's always positive, but there's a negative in the front, so this one becomes negative. So now I just have the other two things in the middle to worry about. In between negative 0.53 and a positive 0.65, there has to be a 0. So f of 0 is another one I'm going to use. When I plug in 0, this is gone, so that's negative. Okay, so when I plug in 0, that's going to be negative. Then in between 0.65 and 2.88, I can technically use 1 or use 2, but 1 seems a lot easier to deal with. So 1 to the third is going to be 1 times negative 4 is going to be negative 4. Okay, plus 12 minus 4 looks like it's about positive. So that's that. So with that, I can write my increase, decrease. Ready? It's going to be increasing from negative infinity all the way to negative 0.53. And again, you can use bracket or parentheses. Your book uses bracket per definition. I normally like to use parentheses. Union that with 0.65 all the way to 2.88. So that's increase. Now decreasing, I did the work for it already, so I'm just going to write the answer. B. So that's decrease, right? Is when the derivative is less than 0. That's B, yep. So based on my number line, it's less than 0 from negative 0.53 all the way to 0.65, or from positive 0.288 all the way to infinity. What was C? Concave. C, tell me when it's concaving up. C, concave up, okay. Now, concave up, I now need to do y prime prime, okay? So I need to do the second derivative of my first derivative. Ready? F prime prime of x is negative 4x to the third. The derivative is negative 12x squared. 12x squared, the derivative of that is positive 24x. And then the derivative of negative 4 is 0. Again, same thing. I'm just going to make sure I set it equals to 0 so I can solve for when the second derivative is actually 0. Looks like I can take out a negative 12x. If I take out a negative 12x, I'm left with a positive x minus 2. So I have two locations when f prime prime is 0. And then I'm just going to do the same thing. This is f prime prime of x, okay? Two locations, 0 and 2. And I'm just going to use the end behavior. As x approaches infinity, I'm going to use negative 100. Here is my second derivative right there. Negative 100 squared is always going to be positive, so with the negative 12 on the front, that's, whoa, not highlighter, okay. With the negative 12 in the front, that's always negative, so negative right there. The other side, I meant the first one's negative infinity, okay, and then positive infinity. It's going to be positive 100 equals to, always going to be negative due to the fact that there's a negative 12 in the front, okay, so those two sides are negative. In between 0 and 2, I will use 1. So f of 1 is 1 squared is 1 times negative 12 is negative 12 plus 24, so that's positive. So when is it concaving up? Concaving up only between 0 and 2. So all of that work, okay? But that will also help me answer D, which is concaving down. Oh my gosh, did I use up the whole page already? Concaving down from, let's see, negative infinity all the way to 0 or to infinity, because concaving down is when the double derivative is less than 0. Next. I did D, E, local extreme values. Local extreme values, let's talk about, I'm out of space in the bottom. So let's go, that's D, this is E. Local extreme value, let's talk about local min first. Local min is when the graph changes, the first derivative changes from negative to positive. Okay, so I'm going to look at this thing right here, because all the work is pretty much done for us. So the answer is, it changes from negative to positive at 0.65, okay? And what else? And that's it, okay? So local min, I need to plug in though, local min of what 0.65 was to the original function. Let me see, does it say values? Yeah, so that means I need to plug it in. Local min is at x equals 0.65. Then I need to plug in f of 0.65 is, let me use my calculator, so hold on tight. You should do the same thing to make sure that we're doing the same, check my math. All right, negative x to the fourth. So negative x to the fourth, so that means I need to plug in 0.65. Okay, and then plus 4 times, why 0.65, so 4 times 0.65 to the third, 0.65 raised to the third, minus 4 times 0.65, then plus 1. So let's double check my calculation. Negative 0.65 raised to the fourth plus 4 times 0.65 raised to the third minus times 0.64 plus 1 at the end. My calculation came out to be about negative 0.73. Okay, if I'm using 0.65. So with that, local min is at, let's just fill in is and then at, okay? Local min is negative 0.73 at x equal to 0.65. And I can do the same thing for local max, but I need to plug it in first before I start writing out, okay? Local max is when the derivative changes from positive slope to negative slope. So it looks like I have this guy right here and I have that guy. So I have two locations, so let's plug in both. F of negative 0.53 is, and F of 2.88 is. Okay, let me punch it in, so don't mind me. Just be a second. Negative 0.53, negative 0.53. Again, just be patient. Negative 0.53. You have to plug in negative 0.53, negative point. So it looks like I have 2.45. So 2.45. You know what? I'm using the last entry, and I just realized that one of them I enter in 0.64 instead of 0.65. So that's going to change a little bit. So let me fix that really quick, to all of it to be 0.65 to see if my value is going to change. It changes to 0.68. Whoops. Sorry guys. But I got one decimal wrong and it changed that right there. Sorry about that. Okay. So now I will go back and enter in 2.88. Ready? Sorry, it's going to take me a little while to punch it in. So 2.88, about 16.23. So you have two max locations, okay? And by now, I think you guys are pretty good with this. L max is 2.45 at x equal to negative 0.53 and 16.23 at x equals 2.88. So that's L max. Our last one, it's F, it's inflection point if we have any. So that's, I'm gonna try to squeeze that in. Sorry if I have a lot of space, you probably don't. But I'm gonna write F over here. I have infinitely, right, many. Right, inflection point is when the double derivative is positive on one side and negative on the other side. All right, I already did the graph for double derivative. It's right here. Okay. So do we have a location that states that when the double derivative is positive on one side and the negative it's on the other side, or vice versa? Sure, actually both locations, right? Or vice versa. So x equals to 0 and x equals to 2. Now I have to plug it back in. Ready? F of 0 just happened to be 1. F of 2 is going to come out to be 9. So those are your inflection points. 0, 1 and 2, 9. Okay, and that's the end of 4A.